What is going on, guys? It's Bucky and welcome to your 17th chemistry tutorial. In this tutorial I'm going to be talking to you guys about radiation or radioactivity or radioactive decay, whatever the heck you want to call it. So unfortunately this has nothing to do with a radio in your car. The definition is the process by which an unstable atomic nucleus loses energy by emitting ionizing particles or radiation. Simple enough? Okay, let's move on to the next tutorial. I'm just kidding, I'll explain it a little bit better. So, certain isotopes are naturally unstable, and by this I mean sometimes their nucleus spontaneously decays or breaks apart. Now, whenever this happens, we call it radioactivity. And you're saying, okay, Bucky, what the heck would cause an isotope or its nucleus to start decaying or breaking apart? Well, if you remember, in the nucleus of an element, you have all of these protons that are jam-packed together really closely. Now, if you remember the rule that opposite forces attract, which would mean that these similar forces, all of these positive charges, are going to be repelling each other. So all of these protons are basically pushing against each other, trying to get away from each other. So you're saying, okay, that makes sense, but then wouldn't the nucleus of an atom just always break apart and explode like instantly? Well, yes, however, you have something called nuclear glue. Now, nuclear glue, first of all, it sounds like a term that I just made up off the top of my head, but this is actually a legit chemistry term. It's what chemists call the force that hold protons together, keeps them from breaking apart. However, sometimes this glue just isn't strong enough to compete with the force of the protons repelling each other, and it starts to break apart. And when that happens, your nucleus starts to break apart, and this is called radioactive decay. Simple enough. So that's pretty much what radioactivity, radioactive decay is, and some other interesting stuff happens sometimes as well. So another thing that you may want to remember before you start these tutorials is the number 84. Let me write that a little bit better. 84. Now this is important to remember because any element with 84 or more protons is naturally unstable. And when I say unstable, I mean it is gonna split apart eventually. It may be a short time, it may be a long time, but any element with 84 or more protons in the nucleus is eventually gonna decay sometime. Now, radioactivity is also related to the proton-neutron ratio of an atom. Typically, you want your ratio to be 1 to 1, or in other words, you want the same number of protons and neutrons in your nucleus. Whenever this happens, your atom is happy and it's stable. However, sometimes the ratio gets kind of out of control. In other words, you may have a high number of protons compared to neutrons, or a high number of neutrons compared to protons. The more uneven your ratio is, the more radioactive an isotope becomes. Simple enough. So just remember those two rules, 84 and the PN ratio, as I like to call it. No one else calls it that, but hey, these are my tutorials. I can call it what I want. So now let me talk to you guys about alpha particles or alpha emissions. Now if we look at the definition, it says a positively charged particle of a helium nuclei. Now we know that helium always has two protons in its nucleus, and also it also has two neutrons. However, since this is positively charged, if we would draw this, we would see that it would have 0 electrons. So the formula for an alpha particle is 2 protons plus 2 neutrons plus 0 electrons. Pretty weird, huh? Now, typically, or I guess I might want to take a step back. So since you have two positive charges and no negative charges, you have an overall +2 or a 2 plus charge. And whenever you have a positively charged ion, it's technically called a cation. Now, since electrons are really easy to gain or lose in nature, this ion typically picks up, it finds two electrons somewhere. So typically whenever you have an alpha particle, it quickly finds two electrons, and this alpha particle quickly becomes a stable or neutral helium element, or helium atom, whatever you want to call it. So aside from that, let me go ahead and give you an example of when this would happen in nature. Let me think of a good color. I'm feeling dark blue. So say you have something like 238 90 to uranium. Now this could break apart and undergo radioactivity, and it would turn into 23490 thorium and also 4,2 helium. And this thing right here, this helium, this would be the alpha particle. Again, as soon as it starts breaking apart, it would have 2 protons, 2 neutrons, and 0 electrons. So this alpha particle would not have any electrons at first. However, it would find them somewhere and quickly become a stable helium element. But at first, it would just be an alpha particle. Now, alpha emission is one type of radioactivity that it's kind of a common type, but there are a bunch of different types that I have to talk to you guys about. This is only the first one I want to cover. So again, to recap one last time, sometimes you have 23892 uranium, and it breaks apart the nucleus, so it breaks into 2 different elements. One is 23490 thorium, and your other is your alpha particle, which is 4,2 helium without any electrons. And then that alpha particle is going to go whiz around and find up 2 electrons, and it's going to become a stable 4,2 helium atom. So again, that is the basics of alpha emission. However, we have to talk about beta emission and all this other kinds of radiation, and it gets pretty interesting. So that's what you have to look forward to in the upcoming tutorials. But for now, thank you guys for watching. Don't forget to subscribe, and oh yeah, add me on Google+. I'll see you later.